Hello, hello. You must either really love math or you must be extremely crazy. Or both. I know I am. Alright, this is Tau Day. Well, tomorrow's Tau Day, and I'm here to explain why Tau is a better circle constant versus the ugly, ugly enemy we're going to be facing called pi. First off, I want to make a point that circles are awesome. They're awesome. Come on. Give circles some props. You learned about rectangles in like 3rd grade. And let's face it, all rectangles are just a bunch of triangles. And you used formulas and you're like, length times width, let's take two numbers and multiply them and plop a unit on it. Circles are fascinating because they use this. They use an irrational number. They use a transcendental. They use something that supercomputers are still calculating today. Trillions upon trillions of digits are coming out of the most advanced supercomputers, all for a circle, okay? All to get more exact, even though it's not really necessary. So yeah, circles are everywhere. Globes, Super Mario coins, galaxies, planets, pizza, even the things you wouldn't consider circles, like billboards. I mean, what do you think billboards, support on? Circles. Yeah. So I want to take a look at how pi has progressed through an education standpoint. So let's look at how you were trapped. So for 5th grade, you took pi formulas and you're like, all right, I don't know what this is, but I have a number. Let's plug it in and see what happens. So you worked with the circumference of a circle, 2 times r times pi, 2 pi r. You worked with the area, pi r squared. This is actually pretty cool. This is Veritasium doing a take on the most perfect sphere we've ever yet to create. This is exactly 1 kilogram. I thought it was pretty neat. They took months sandering it out, making it perfect to use. All right, anyway, so since this is a 3-dimensional object, you work with things like surface area. So surface area, you get crazy things like 4 pi r squared. And volume, like 4/3 pi r cubed. And you wonder where your sanity has went. Alright, how did it get from pi r squared to a 4/3 pi r cubed? I don't know, but let's go with it. And then you have this log type thing, which is meant to represent a cylinder. So you have the surface area, you have this 2 pi r squared plus 2 pi r times the height. The volume is pi r squared times height. My point in all this is showing you that pi is everywhere, dealing with not only circles in 2 dimensions, but 3 dimensions, and someday, maybe, 4 dimensions, and beyond. So you took pi, and you said, all right, pi is 3.14, or 3.14159, or 3.14159265359, or you just hit the pi button on your calculator, because you really, let's face it, I didn't want to remember all those stupid digits. So all you had to do is take the radius, plug it into a formula, you're done. This is 5th grade math. You were happy and you didn't realize that you walked into a trap. It's a trap. Yeah, you better call Victor because you are screwed. Alright, let's talk about trigonometry for a second. If you don't have extensive knowledge of trig, that's okay. I don't have extensive knowledge of trig, but I'm doing this video. So at least kind of know the basics in terms of radians, at least maybe have looked at a unit circle. Okay, so this is a common problem in trig. And when you look at it the first time, you might read it as this. A central angle, theta, hold up, did you just use a Greek letter? Whatever, a central angle theta of a circle measures 30 degrees. If a unicorn's horn measures 20 memes, how far can I go on my diet until I arc out of my car window? That's what you read it as. And then you go back, you slap yourself in the face, douse yourself with cold water, and you read it again. But honestly, why do people have problems with this? It's a simple formula. It's S equals R times theta. The problem is theta. It's the angle measurement. And the angle measurement deals with a circle. And what do we know about circles? They deal with pi. So the problem is basically this. I'm trying to convert 30 degrees into radians, and I'm having trouble. I don't know what 30 degrees is in radians. I have to think about it for a second. I have to say, all right, here's 30 degrees. 30 degrees is right here. And I have to say, all right, well, if one trip around this entire circle yields 360 degrees, then 30 degrees is actually just a 1/12 of that, right? It's just a 1/12. Okay, so converting it to radians, I get that 30 degrees is, get this, pi over 6. Wait, where did this 6 come from? I thought we were just talking about a 1/12 of a circle. And now we're talking about 6? All right. So then you talk about the unit circle, and then you do this for some other angles, like 90 degrees. All right, let's talk about that, quaternal. So I go 1/4 around the circle, and it turns out that in radians, we're talking pi over 2 radians. I go halfway around the circle, and we talk pi radians. I go one trip around the circle. This is what it comes down to. I go once around the circle, and we have 2 pi radians. How confusing is that? If I'm learning trig, I don't want to be taught that once around is 2 pi radians. Okay? So, what's the possible solution? Tau. And you know it's good because it rhymes with, yeah, you get it. Alright, so yeah, tau equals 2 pi. Now, if you have a PhD in math or theoretical physics where you think you know what you're talking about, then you can just say, oh, why even have this stupid argument? Just convert. I mean, if you don't like tau, switch it to 2 pi. If you don't like 2 pi, switch it to tau. But that's not the point. The point is 2 pi appears way too often to not notice it. And you should replace it with something that is beyond simple. Okay? So yes, tau is equal to 2 pi. That's our definition. If you want to know where this definition came from, you are happy to read the Tau Manifesto by Dr. Hartle. It's a lot of work, and you might not understand all of it until you take like really advanced classes, but you get the picture. So I pulled this up off of a physics website, the College Board. So for AP Physics, they give you a reference sheet because it's physics, and you have so many things to cover. So this is 3 years dated, but I took the liberty of taking all the formulas with pi, putting them on this next slide, and you see that there are 3 of them. What do you notice about all 3 of those formulas? Oh, I don't know. They have 2 pi. Where did that 2 come from? I'll tell you where that came from. These formulas down here deal with periods in springs. Springs go back and forth repeatedly over a specific time interval. And this has to deal with magnetic flux. So you have a particle doing some weird behavior over and over again. So yes, what do these formulas have in common? Dealing with 2 pi. We're dealing with waves. Yes, waves. Well, not exactly, but you get the picture. So you're dealing with waves. Bringing me to my next little order of business. Let's graph a wave. Let's graph a period y equals sine of x. In a traditional trig class, it works out like this. All right, so I'm going to start here because it's sine of x. Now I have to figure out what sine of pi over 2 is. Remember, sine is the y-coordinate on my unit circle. So I have to remember where pi over 2 even is. What are we talking about here? 1/2 pi. So a common mistake is, oh, it's 1/2 around the circle. No. Wait. Pi over 2 is 90 degrees. So pi over 2 is right here. The y-coordinate is 1. You see what kind of stress that is? And you have to do that for all of these. If you don't have a unit circle out, then you are struggling to think of these values. If you don't, then I mean, power to you. Good job. But for most people, you're really struggling. So, took the liberty of getting a blank graph. And now let's do this in terms of tau. Okay, tau. So this is 1, this is -1. All right. So, 0. I have it moved all on my unit circle. What's my y-coordinate on the unit circle? 0. All right. So let me go ahead and draw that. I go a fourth around the unit circle. So I go tau over 4, a fourth around the unit circle. What's this y-coordinate? 1. Okay. So now I go 180 degrees. So I go halfway around the circle. Tau over 2. What's my y-coordinate now? 0. -1, 0. This becomes so easy when you think about it in terms of pi, because you don't have that annoying factor of 2. You want to punch in the face. Okay? I just want you to think about this for a little bit, and I want you to think about why tau is much simpler. Right? And yes, if you do some research on this, you have on one side the pi people, and they say, oh, pi is fine as it is. You don't need to change any of our formulas, because if you do, then it messes things up. Pi r squared. Do you really suggest changing pi r squared to r squared tau over 2? And then you have the Taoists that say, oh, well, you have all these physics formulas with 2 pi, and I can just replace it with my tau. That's not the point. It's not the point to compile lists of thousands of formulas that work for my case and this case, and just like get a room, you two. I mean, like wrestle it out or something. No, the point is, if you're learning trigonometry and you're learning all about this 2 pi radians, that messes everything up. Okay? Messes everything up, and you need to replace it with tau. Make things way simpler for you. And if you understand it, then you're way better off. Much more people would understand trig if that happened, and much more people would understand math. So I was encouraged to make this video by a few things. Tau Manifesto by Dr. Hartle. Weihart's video, I would definitely check it out, where she definitely explains that Pi Day 3.14 is not ruined June 28th because tau equals 2 pi. Join on Tau Day, so you get twice as much of the goodies. Finally, I took the liberty of reading a college trig book. I needed to catch up on some things. And the fact of the matter that they took an entire trigonometry book and changed all of it so that it only worked with tau. I thought that was extremely inspirational. Anyway, that's the end of my little rant. I thought that hundreds of people made videos on this, I would give it a shot. So comments, questions, concerns, whatever you want are greatly encouraged, so I cannot make those same mistakes in the future. Alright, this was my video, and I hope you found it helpful.